The National Council of Examiners for Engineering and Surveying (NCEs) has introduced an Architectural Engineering Professional Engineer (P) exam. This exam is specifically designed for professionals in the construction field. The Architectural Engineering PE exam focuses solely on electrical engineering concepts related to building construction. It does not include topics such as direct current circuits, diodes, or electronic theory. This exam is an excellent option for those with practical experience in the construction industry who may not possess a strong electronics background. The Architectural Engineering PE exam aligns with the specific knowledge and skills required for building wiring. Passing the exam grants you a PE license, demonstrating your expertise in the field, which can enhance your career prospects and credibility within the industry. The Architectural Engineering PE exam covers topics such as electrical power distribution, lighting design, and electrical safety codes. It consists of 90 multiple-choice questions and has a time limit of 4 hours. This exam provides a valuable pathway for building wiring professionals to demonstrate their expertise and advance their careers. By leveraging practical knowledge and experience, individuals can obtain a PE license without the need for an extensive electronics background. To register for the exam, please visit the NCE's website. Electrical power distribution involves the systems and equipment that deliver electrical power from the utility source to the various loads within a building. This includes transformers, switchgear, panel boards, feeders, and branch circuits. Understanding the principles of power distribution is crucial for ensuring a safe, reliable, and efficient electrical system. Load calculations are essential for determining the appropriate size and capacity of electrical equipment. They involve calculating the total electrical demand of a building, taking into account various factors such as lighting, receptacle outlets, appliances, and HVAC systems. Accurate load calculations ensure that the electrical system can handle the anticipated load without overloading or causing voltage drops. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a predetermined level, preventing damage to equipment and reducing the risk of fire. Grounding and bonding are critical safety measures that provide a low-impedance path for fault currents to return to the source. Grounding establishes a connection between the electrical system and the earth, while bonding connects all metallic parts of the electrical system together. These measures help to minimize the risk of electric shock and ensure the proper operation of overcurrent protection devices. Voltage drop occurs when the voltage at the load is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction and reduce the efficiency of the electrical system. It is important to select conductors of the appropriate size to minimize voltage drop and ensure that equipment receives the proper voltage. Lighting design involves the selection and placement of lighting fixtures to provide adequate illumination for various tasks and activities. It also considers factors such as energy efficiency, visual comfort, and aesthetics. Proper lighting design can improve productivity, reduce high strain, and create a more comfortable and inviting environment. Illuminance is the amount of light that falls on the surface measured in foot candles or lux. Recommended illuminance levels vary depending on the task or activity being performed. For example, office spaces typically require higher illuminance levels than hallways or storage areas. Light sources include incandescent lamps, fluorescent lamps, light-emitting diodes, and high-intensity discharge lamps. Each type of light source has its own advantages and disadvantages in terms of energy efficiency, color rendering, and lifespan. Lighting controls, such as occupancy sensors, dimmers, and timers, can be used to reduce energy consumption and improve the efficiency of lighting systems. These controls automatically turn lights on and off or adjust the light level based on occupancy, daylight availability, or time of day. Electrical safety codes are a set of regulations and standards that ensure the safe installation and operation of electrical systems. These codes are typically based on the National Electrical Code, NEC, which is updated every 3 years. Adherence to electrical safety codes is essential for protecting people and property from electrical hazards. The National Electrical Code (NEC) is a comprehensive set of standards that covers all aspects of electrical installations. It provides detailed requirements for wiring methods, overcurrent protection, grounding, and other electrical safety measures. The NEC is widely adopted by jurisdictions throughout the United States and serves as the basis for most state and local electrical codes. Wiring methods refer to the types of cables and raceways used to install electrical wiring. Common wiring methods include non-metallic sheath cable, armored cable, and electrical metallic tubing. The NEC specifies the allowable wiring methods for different applications and environments. Ground fault circuit interrupters (GFCIs) are devices that protect people from electric shock by detecting ground faults. A ground fault occurs when current flows through an unintended path to ground, such as through a person's body. GFCIs quickly interrupt the flow of current when a ground fault is detected, preventing serious injury or death. Arc fault circuit interrupters (AFSIs) are devices that protect against electrical fires caused by arc faults. An arc fault is an unintentional electrical discharge that can occur in damaged or deteriorated wiring. AFSIs detect arc faults and quickly interrupt the flow of current, reducing the risk of fire. In electrical power distribution, transformers are used to step up or step down voltage levels. Step-up transformers increase the voltage, while step-down transformers decrease the voltage. Transformers are essential for transmitting electrical power over long distances and for providing the appropriate voltage levels for different types of equipment. Switchgear is a general term for equipment used to switch, protect, and control electrical circuits. Switchgear includes circuit breakers, fuses, switches, and other devices that are used to isolate and energize electrical equipment for maintenance or repair. Panel boards are enclosures that contain circuit breakers or fuses for protecting branch circuits. Panel boards distribute electrical power to various loads throughout a building. Feeders are conductors that carry electrical power from the service entrance to panel boards or other distribution points. Feeders are typically sized to carry the total load of the circuits they serve. Branch circuits are conductors that carry electrical power from the panel board to individual loads such as lighting fixtures, receptacles, and appliances. Branch circuits are protected by circuit breakers or fuses in the panel board. Electrical safety is a critical aspect of building wiring. Electrical hazards can cause serious injury or death. It is important to follow all electrical safety codes and guidelines to minimize the risk of electrical accidents. Lockout-tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. These procedures involve locking out the power source and tagging it to indicate that the equipment is being worked on. Personal protective equipment (PPE), such as rubber gloves, safety glasses, and insulated tools, should be used when working on electrical equipment. PPE provides protection against electric shock, arc flash, and other electrical hazards. Electrical permits are required for most electrical installations. Permits ensure that the work is performed in accordance with electrical safety codes and that the installation is inspected by a qualified electrical inspector. The three-phase power system is a common method of electrical power distribution. In a three-phase system, 3 alternating current AC voltages are used, each separated by 120 degrees. This system is more efficient than a single-phase system and is used for most commercial and industrial applications. A single-phase power system is a simpler method of electrical power distribution, commonly used in residential applications. In a single-phase system, a single AC voltage is used. The voltage in a single-phase system is typically 120 volts or 240 volts. The electrical drawings and diagrams are used to represent electrical systems. These drawings and diagrams show the location of electrical equipment, the wiring connections, and the circuit pathways. Electrical drawings and diagrams are essential for designing, installing, and maintaining electrical systems. A one-line diagram is a simplified representation of an electrical system. It shows the major components of the system, such as transformers, switchgear, and panel boards, and the connections between them. A schematic diagram is a more detailed representation of an electrical circuit. It shows the individual components of the circuit, such as resistors, capacitors, and transistors, and the connections between them. A wiring diagram shows the physical connections between electrical components. It is used to guide the installation of electrical wiring. The unit of electrical current is the ampere, amps. An ampere is a measure of the rate of flow of electrical charge. The unit of electrical voltage is the volt, volts. A volt is a measure of electrical potential difference. The unit of electrical resistance is the ohm, ohms. An ohm is a measure of the opposition to the flow of electrical current. Ohm's law states that the voltage across a resistor is equal to the current through the resistor times the resistance. Ohm's law can be used to calculate the voltage, current, or resistance in a circuit if the other two values are known. Power is the rate at which electrical energy is transferred. The unit of electrical power is the watt, watts. 1 horsepower is equal to 746 watts. The power formula is power equals voltage times current. This formula can be used to calculate the power in a circuit if the voltage and current are known. Energy is the capacity to do work. The unit of electrical energy is the kilowatt-hour, kilowatt-hours. A kilowatt-hour is the amount of energy used by a 1 kilowatt device for 1 hour. Electrical meters are used to measure electrical energy consumption. These meters are typically read monthly to determine the amount of energy used. Energy efficiency is the ratio of useful energy output to total energy input. Energy-efficient devices use less energy to perform the same task as less efficient devices. Improving energy efficiency can save money and reduce environmental impact. Power factor is a measure of how effectively electrical power is being used. A power factor of 1 indicates that all of the electrical power is being used to do work. A power factor of less than 1 indicates that some of the electrical power is being wasted. Improving power factor can save money and reduce environmental impact. Harmonics are distortions of the electrical voltage and current waveforms. Harmonics can be caused by nonlinear loads such as electronic devices and adjustable speed drives. Harmonics can cause problems with electrical equipment and can reduce the efficiency of the electrical system. Surge protection devices, SPDs, are used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other electrical disturbances. SPD divert the surge current to ground, protecting the equipment from damage. Electrical codes and standards are constantly evolving. It is important to stay up to date on the latest codes and standards to ensure that electrical installations are safe and compliant. Continuing education is essential for electrical professionals. Continuing education courses can help electrical professionals stay up to date on the latest technologies and best practices. The Architectural Engineering PE exam is a valuable credential for building wiring professionals. It demonstrates expertise in the field and can enhance career prospects. By preparing thoroughly and leveraging practical knowledge and experience, individuals can successfully pass the exam and obtain their PE license. Conduit fill refers to the percentage of space inside an electrical conduit that is occupied by conductors. The NEC specifies the maximum allowable conduit fill to prevent overheating and ensure that conductors can be easily installed and removed. The ampacity of a conductor is the maximum amount of current that it can carry safely without overheating. The NEC specifies the ampacity of conductors based on their size, insulation type, and installation conditions. The earthing factors are used to reduce the ampacity of conductors when they are installed in conditions that can cause them to overheat. These conditions include high ambient temperatures, multiple conductors in a raceway, and conductors installed in direct sunlight. Service entrance conductors are the conductors that carry electrical power from the utility service to the building. The size of the service entrance conductors is determined by the calculated load of the building. The grounding electrode system provides a connection between the electrical system and the earth. The grounding electrode system typically consists of a ground rod, a ground plate, or a metal water pipe. The equipment grounding conductor provides a low impedance path for fault currents to return to the source. The equipment grounding conductor is typically a green or bare copper wire. Bonding jumpers are used to connect metallic parts of the electrical system together. Bonding jumpers ensure that all metallic parts are at the same electrical potential, minimizing the risk of electric shock. The NEC provides tables and examples to assist with electrical calculations. These tables and examples can be used to determine the appropriate size of conductors, overcurrent protection devices, and other electrical equipment. It is important to understand the principles behind electrical calculations and to use the NEC tables and examples correctly. The NEC is a complex document, but it is essential for ensuring the safe and compliant installation of electrical systems. By studying the NEC and seeking guidance from experienced electrical professionals, individuals can gain the knowledge and skills necessary to perform electrical work safely and effectively. The Architectural Engineering PE exam is a challenging but rewarding experience. By preparing thoroughly and leveraging practical knowledge and experience, individuals can successfully pass the exam and advance their careers in the field of building wiring. Firstly, understand the NEC. Secondly, practice calculations. Thirdly, review lighting design principles. And fourthly, familiarize yourself with electrical safety codes. Remember that this exam is a new path for wiring pros.